Now question number 6, please listen. Consider the two different first order reactions given below. First one is A plus B giving C, this is reaction number 1. And the second one is P giving Q, this is reaction number 2. The ratio of the half-life of reaction 1 is to reaction 2 is 5:2. If T1 and T2 represent the time taken to complete 2/3 and 4/5 of reaction 1 and reaction 2 respectively, then the value of the ratio T1 is to T2 is dash into 10 raised to minus 1. In bracket nearest integer, it is given that log 3 is equal to 0.477 and log 5 is equal to 0.699. We know for a first order reaction, half-life period T half is equal to 0.693 divided by K. Then for the first reaction, we can write T half 1 is equal to 0.693 divided by its rate constant K1. And for the second reaction, T half 2 is equal to 0.693 divided by K2. Then T half 1 divided by T half 2 is equal to K2 by K1. It is given as 5/2. For a first order reaction, the time taken for the reaction T is equal to 2.303 divided by K into log R0 divided by RT. Thus, for the first reaction, T2 by 3 is equal to 2.303 divided by its rate constant K1 into log initial concentration is taken as 1. Then after completing 2 by 3, the final concentration becomes 1 minus 2 by 3, that is equal to 1 by 3. Thus, T2 by 3 is equal to 2.303 divided by K1 into log 3. This is equation number 1. Now for the second reaction, T4 by 5 is equal to 2.303 divided by its rate constant K2 into log initial concentration 1 and the final concentration is 1 minus 4 by 5, that is equal to 1 by 5. Thus T4 by 5 is equal to 2.303 by K2 into log 5. This is equation number 2. Dividing equation number 1 by 2, that is T2 by 3 of first reaction divided by T4 by 5 of second reaction is equal to K2 by K1 into log 3 divided by log 5. K2 by K1 is given as 5/2 and log 3 is 0.4771, log 5 0.6990. This is equal to 1.7, that is equal to 17 into 10 raised to minus 1. So here the answer is 17. Then question number 7. Consider the following reaction A plus B giving C. The time taken for A to become 1/4 of its initial concentration is twice the time taken to become 1/2 of the same. Also, when the change of concentration of B is plotted against time, the resulting graph gives a straight line with a negative slope and a positive intercept on the concentration axis. The overall order of reaction is dash. Listen please, here the reaction is A plus B giving C. It is given that the time taken by the reactant A to become 1/4 of its initial concentration is equal to 2 times its T half. That is, for a first order reaction, T2/3 is equal to 2 into T half. That means it is a first order reaction with respect to A. It is also given that when concentration of B is plotted against time T, the graph is a straight line with a negative slope and a positive intercept on the concentration axis. Therefore, it is a zero order reaction with respect to B. There are only two reactants in the reaction. With respect to A, it is a first order reaction, and with respect to B, it is a zero order reaction. Therefore, overall order of reaction is equal to 1 plus 0, that is equal to 1. So here the answer is 1. Now question number 8. For a reaction A giving B giving C, the rate constant of A giving B is K1 and that of B giving C is K2. If the rate of formation of B is said to be 0, then the concentration of B is given by option number 1 K1 into K2 into concentration of A, option number 2 K1 minus K2 into concentration of A, option number 3 K1 plus K2 into concentration of A, and option number 4 is K1 by K2 into concentration of A. Here the given reaction is A giving B giving C. That means the reaction involves two steps. The rate constant of the first step is K1 and that of the second step is K2. From this reaction we can say that the rate of formation of B is equal to the rate of the first step minus the rate of the second step reaction. The rate of formation of B can be represented as plus dB by dt, that is equal to rate of the first step reaction, that is K1 into concentration of A, minus the rate of the second step, that is K2 into concentration of B. Here the rate of formation of B is given as 0. Therefore, 0 is equal to K1 into concentration of A minus K2 into concentration of B. That is K1 into concentration of A is equal to K2 into concentration of B. Therefore, concentration of B is equal to K1 by K2 into concentration of A. Therefore, here the answer is option number 4. Now question number 9, listen here. Given below are two statements. Statement number 1, the rate law for the reaction A plus B giving C is rate R is equal to K into concentration of A square into concentration of B. When the concentration of both A and B is doubled, the reaction rate is increased by X times. Now statement number 2, the figure is showing the variation in concentration against a time plot for a Y order reaction. Then the value of X plus Y is dash. In the first statement, the rate law equation for the reaction A plus B giving C is given, that is rate R is equal to a constant K into concentration of A square into concentration of B. When concentration of both A and B is doubled, it is given that the rate of reaction increases by X times. We need to find out the value of X. In the second statement, a concentration time curve is given, which is a straight line having negative slope. Its order of reaction is equal to Y. We need to find out the value of Y. Finally, we want to calculate the value of X plus Y. In the second statement, a concentration time graph is given. It is a straight line having negative slope. Its order of reaction is given as Y. We need to find out the value of Y. Finally, we want to calculate the value of X plus Y. Here the rate of reaction is given as R is equal to K into concentration of A square into concentration of B. When concentration of both A and B are doubled, the rate of reaction becomes R1 is equal to K into 2A the whole square into 2B. 2 square is equal to 4 into 2 is 8. Thus the equation becomes 8 into K into concentration of A square into concentration of B. But K into concentration of A square into concentration of B is small r. Therefore, R1 is equal to 8R. That means the value of X is equal to 8. Here the graph given is of a zero order reaction, because concentration time graph for a zero order reaction is a straight line having negative slope. That means the value of Y is equal to 0. Therefore, X plus Y is equal to, here value of X is equal to 8 and Y is equal to 0. Therefore, X plus Y is equal to 8. So here the answer is 8. Now question number 10, please listen. Consider the following first order gas phase reaction at constant temperature. The reaction is A gas giving 2B gas plus C gas. The total pressure of the gases is found to be 200 torr after 23 seconds and 300 torr upon the complete decomposition of A after a very long time. Then the rate constant of the given reaction is dash into 10 raised to minus 2 second raised to minus 1. In bracket nearest integer, and also given that log 2 is equal to 0.3010. Listen, here the given reaction is A gas giving 2B gas plus C gas. When time t is equal to 0, suppose the initial pressure of A is equal to P0. Then the pressure of B is equal to 0 and that of C is also equal to 0. We know for a gas, pressure is directly proportional to number of moles. Therefore, we can take P0 as the initial number of moles of A. When time t is equal to 23 seconds, assume that X moles of A has dissociated. Then the number of moles of A remaining is equal to P0 minus X. Then the number of moles of B formed will be 2X and that of C will be X. Then after a long time, that is when T is equal to infinity, the number of moles of A will be completely reacted. Therefore, the remaining number of moles of A will be P0 minus P0 and the number of moles of B formed will be 2P0 and that of C will be P0. Now the total pressure when time T is equal to 23 seconds is equal to P0 minus X plus 2X plus X, that is equal to P0 plus 2X. It is given as 200 torr. Then the pressure after infinite time, that is P infinity, is equal to 2P0 plus P0, that is equal to 3P0. It is given as 300 torr. From this, P0 can be calculated. It is equal to 100 torr. Then for a first order reaction, the rate constant K is equal to 2.303 divided by T into log P infinity minus P0 divided by P infinity minus Pt. Here the time T is equal to 23 seconds and P infinity is given as 300 torr. Pt is equal to 200 torr and P0, its value we have calculated as 100 torr. Then substituting these values in this equation, the equation becomes K is equal to 2.303 by 23 into log 300 minus 100 divided by 300 minus 200. That is K is equal to 2.303 by 23 into log 2. Log 2 is 0.3010. Therefore, K is equal to 3.01 into 10 raised to minus 2 second raised to minus 1, which is approximately equal to 3 into 10 raised to minus 2. So here the answer is 3.